Hello and welcome to Physics with Tech. This lesson should be given on Monday, March 19th. As I give this lesson, there may be times when I ask the video to pause. So if you're the substitute, if you could please make sure that the video gets paused at the appropriate times so that students can do some of the work in their packets. Students, you're going to need your new blue packets. As we follow along in this lesson, I expect you to take notes as if I were there in class. So make sure that you're listening and paying attention and filling out your notes packet as we go. Because it's a Monday schedule, we're not going to do a quiz today, but there will be a quiz on Wednesday and Friday, so make sure you're prepared for that. The questions in your quiz will all come from the blue notes packet. The topic today is the independence of dimensions. The word independence is something that Americans love. To be independent means that you're free from outside influences. So in America, the war for independence was when we fought against England, because we didn't want England to tell us what to do. Well, today we're going to learn that physics also has some independence principles, and they actually make the math a lot easier and allow us to do some cool things. So in your blue packet, you want to make sure that you are on the second page. It's called the Independence of Dimensions. And fill out your notes as we watch the video. The independence principle. You want to copy this in your notes. What happens in one dimension has no influence on what is happening in the other dimension. Now, when I use the word dimension, I'm talking about the x dimension and the y dimension. So really what this principle tells us is that what happens in the horizontal direction has no influence on what is happening in the vertical direction. This may seem like a simple concept. Basically, the x dimension is independent of the y dimension. They can't tell each other what to do. But you're going to see that even though the concept is simple, applying it correctly can actually be harder than you think. Before we continue, let's talk about some of the words we use with each dimension. The main word in the x dimension is horizontal. When we talk about x dimension forces and such, we're talking about horizontal forces. The words that you want to watch for are left and right, and we will sometimes use the words backward and forward. So again, all of these words are associated with the x dimension, and you need to recognize that if you see them. In the y dimension, the main word that we use is vertical. And to distinguish the different vertical directions, we use up and down. So if you see any of these words, you need to associate them with the y dimension. All right, we're going to start by looking at a basketball that has been thrown towards the hoop. As it moves, not only is it moving up and down, it's also moving forward. That means that the ball has both horizontal motion and vertical motion. The independence principle says that I can look at each of these separately. So that's exactly what I'm going to do. And I'm going to start by looking at what the ball is doing horizontally. So when the player pushes the ball forward, he gives it some horizontal speed. And as the ball continues forward, it actually keeps the same horizontal speed. In other words, it moves forward at a constant rate. What you need to write in your notes is that the ball moves forward at a constant speed. Meanwhile, the ball is doing something very different in the vertical dimension. When the player throws the ball and it leaves his hands, at first it's moving up really fast. But gravity soon finds the ball and slows it down until finally the ball runs out of upward velocity, and for just a brief second it will stop as it turns around and prepares to come back down. On the way down, it starts off slowly, but then gains more and more speed as it falls. The reason this is happening is because of gravity. So what you want to write in your notes is that gravity changes the vertical speed of the ball by 10 meters per second every second. Now, remember that the ball is moving both horizontally and vertically at the same time. So let's put all of these arrows together and see what picture we form. The red arrows show the ball moving forward, and the blue arrows show the ball moving up and down. When we combine them, we get a path that is shaped like a parabola. Those of you that have played basketball or football know that when you throw a ball, it follows a parabolic arc as it moves towards its destination. The reason this is happening is because the y dimension is being affected by gravity, but the x dimension is being constant. And when we combine this, we get a perfect parabola. Now, there's a lot of misunderstandings with how gravity works, so I want to talk for a minute about some of these common misunderstandings to make sure that when we analyze stories, you are doing so correctly. The first thing that you want to write down is that gravity does not affect the horizontal speed of a projectile. In other words, gravity will never make you move forward faster. That's not how gravity works. Gravity is trapped in the vertical dimension. It cannot escape from the y dimension. It cannot pull sideways. It can only pull down. So I never want you to tell me that a basketball is gaining horizontal speed because gravity is pulling on it. The second fact is that gravity is the same at all points in the trajectory. It is always 10 meters per second in the downward direction. So when you first throw the basketball, what is its acceleration? The answer is 10. At the top of its trajectory, what is the basketball's acceleration? The answer is 10. And on its way back down, what is the basketball's acceleration? The answer is 10. It's always 10. The reason this is confusing is because the speed of the basketball is changing. It starts off going upward, and then it loses speed, turns around, and comes back down. Because the speed is changing, and because of the direction of the ball changes, most students think that the acceleration changes, and they usually think that it changes in the middle, at the very top of the trajectory. However, in order for the acceleration of the ball to change, gravity would have to suddenly either change in strength or direction. Now that's just silly. Gravity is not going to suddenly turn itself off halfway through the trajectory And gravity is not going to suddenly change directions halfway through the trajectory. Okay, gravity is always 10 meters per second in the downward direction. The third fact is that gravity acts immediately. When you release the basketball, it doesn't take a few seconds for gravity to find the basketball. As soon as it leaves your fingertip, it is already beginning its parabolic path. A good example of the third fact done wrong is the Wile E. Coyote effect. If you've watched the Roadrunner cartoons, you've seen Wile E. Coyote running off of a cliff, and at first he's fine. It isn't until he looks down and notices that there is no ground that he begins to fall, and then he always falls straight down. This is ridiculous, and this is not what happens in real life. In real life, gravity is going to find Wile E. Coyote as soon as his toes leave the edge of the cliff. So his true path is going to move him forward at a constant speed, and then he will gain downward speed as he falls. Again, when you put this motion together, you get a parabola. We are now going to look at a few examples of the independence principle, and you will have a chance to discuss these with your groups. So, example number 1. A bullet is fired horizontally, that means straight to the side, from a gun. At the exact same instant, a second bullet is dropped from the height of the gun. Our question is, which bullet will hit the ground first? If you are the substitute, will you please pause the video now and give each table some time to discuss this? They need to write their answer in their note packet and then invite a few of the groups to share their ideas with the class. Okay, now we need to look at the real answer. Let's see if your group got it right. The bullet that was fired from the gun will fall 10 meters per second towards the ground. This is because of gravity. Gravity finds the bullet immediately and starts to pull it down. Meanwhile, the bullet that was dropped also falls 10 meters per second towards the ground. Notice that in the y dimension, or vertical direction, both objects are doing the exact same thing. So it shouldn't surprise you that they will actually reach the ground at the exact same time. It doesn't matter that the fired bullet is moving forward really fast. They will still hit the ground at the same time. Make sure that you jot down the real answer in your notes so that you can remember what the correct answer was. In this case, it is a tie. Both bullets hit the ground at the same time. Now, some of your groups may have gotten this right, in which case, good job, you're very smart, but some of the groups probably did not get this right. And some of you may not believe me even after I tell you. So there's an episode of Mythbusters where they actually tried this out to see if it would really work. And we are going to watch that video clip. So this is the end of the first video. When it closes, make sure you minimize this video and then start playing the next video in the assignment.